Okay, so I need someone to wave to make sure that I know you're okay. Very good. Hello, Oliver. Welcome to everyone. Thank you very much for joining us at this SydCHI chapter talk. We're delighted to have Dr. Barrett Ens from Monash University joining us today. Barrett's actually a lecturer in the Faculty of Information Technology. Previously, of course, many of us will have known him from his work in Manitoba, or you might have known him from his work when he was in Autodesk Research, or even possibly when he was working in the University of South Australia. But now he's faculty in Monash, and he's currently here in Sydney on sabbatical. So if you'd like to meet up with Barrett while he's here for the next few months, please get in touch with him. He's looking for collaborations and looks forward to the opportunity to meet all of you. But of course, Barrett is very well known for his work in data, immersive analytics. He's been doing lots of work in maturing augmented reality, connecting that with the Internet of Things and wearable computing. His supervision interests, or the students he currently works on with, are looking at things like spatial user interfaces, some novel input methods, some wearable devices, but also looking at situated data analytics and visualization. And I'm looking forward to learning more about Barrett's work today. Thank you very much for joining us, Barrett.
Oh, my pleasure. Thanks for inviting me. And thank you for the introduction. Can you hear me okay? Yeah, all good? Okay. Shall I go ahead and start then? Oh, host has disabled screen sharing. Can you turn screen sharing on for me, please? Who's the host? Don? Don is the host.
While we're doing that, figuring out the screen sharing, if anyone has any questions for Barrett about his existing work or about his time in Sydney, like where is he based, where is he working on, now would be a good time while we figure out how to get the technology to work.
Yeah, I wondered, Barrett, where you're sitting.
I'm in the Innovation Hub. So I'm over here on one side of the room. I'll give you a panorama. Aaron and everybody else are way over there on the other side of the room, so I can sit here without my mask. So if you hear some echo, that's why. So it's in the, was it the Kensington campus? Is that right?
Yeah.
Yeah. Any other questions? Anybody have any prescient questions? Ask me about my talk before the talk. Is there anything you're about to see that you would like me to elaborate on? This makes it easy. Let's see who's here. Recognize a few faces. Thanks for joining, everyone. Did you got? It's working now. Okay, great. So we'll just jump in here now. And great. Can everybody see that? I'll assume that's a yes.
Yes.
Let me just slide this there and okay. Yeah, so I'm Barrett Ens, as Aaron mentioned. I am from Monash University in the Data Visualization and Immersive Analytics lab. I've been there for about 3 years or so, and yeah, really happy to be here today. The title of my talk is Using Space Around Us for Data Exploration. So I'm gonna start by, oh, my arrow key doesn't work. Oh, there we go, okay. So I'm going to start talking about this. Does anybody recognize this guy? It looks like Benedict Cumberbatch, but it is in fact Sherlock Holmes from the BBC version of Sherlock Holmes. And if you've seen the show, you know there's a lot of emphasis on this idea of the memory palace. So Sherlock is often going into his memory palace where he has this amazing storage of facts. And this works by him having a picture of his living room, and he has all of these kind of facts stored in specific places in his mind. So this is actually a real memory technique that people use in memory competitions and stuff. And it essentially, it originates from ancient Greece, from something called the method of loci. But this kind of technique goes much back further than that. So there's something called song lines. So Aboriginal song lines, if you're not familiar with this term, these are stories that connect knowledge with places and stories. So it's kind of a storytelling technique where elders pass down knowledge from generation to generation, and involves telling a story over physical locations and different places. And in fact, there are these star maps are used in some of these song lines, and the star maps kind of represent maps to different places. So people used to use these as navigation aids. So each star is attached to a specific location, for instance, a watering hole, and they would use these to kind of navigate the landscape. And then it turns out these have actually helped turned into the modern highway network that we have now. So some of these highway networks that we have are actually thousands and thousands of years old, based on these song lines. On the right is some of the highway networks across Australia. So I came across this study very recently. This is a study from 2021 from a group of people at Monash. This is not my research group, but I was reading about this, and they did a memorization study where they had a bunch of participants, and they wanted them to remember these 20 butterfly names. So 20 names of common butterflies. And, the baseline technique, they gave a set of participants, they could basically do this however they wanted. And there's another group of participants where they asked them to use this memory palace technique. So they would create this kind of mental spatial map of, to help them remember the names of these butterflies. And there's another group that used this Aboriginal technique based on song lines. So they took them around this garden, and they had an Aboriginal storyteller that would associate, essentially tell a story and talk about different butterfly names in different locations around the garden and associate them with the story. And it turns out that in the basic memory technique, people are about 50% better at recalling the butterfly names, but the memory palace, they were two times better. They could recall 2 times as many butterfly names, and with the Aboriginal technique, it increased memory even better. And in fact, they found that not only did the Aboriginal technique increase the recall, but the participants remembered the correct order more often of the butterflies. So I guess the takeaway from all of this is that, we have, it's very common in ancient cultures, and just kind of building on an innate ability that we are able to associate things, information with physical space. Right? So
Something I should have asked at the beginning was, would you like to take questions during the talk, or would you like to take questions at the end?
Let's maybe wait until the end, just because I think then, just for the sake of time, and then I'll try and with about 15 minutes early, and we can take them at the end.
Thanks, Aaron. I'll hold off. Thank you.
Okay. All right. So because I actually have too many projects in this set of slides, so I'll try and get through quickly. In user interface design. So we actually use these techniques of allocating things in space to assist our memory of interface design, of course, right? So we have this kind of desktop metaphor where it helps us to remember the locations of icons, items in the toolbar, and menu items. So these are all based on, our sense of space and spatial memory to help us navigate these things, right? And the desktop metaphor in itself is intended to be, a sort of a simulation of a physical desktop to enable this. Right. So the question is, why use spatial interfaces? So spatial memory, I already talked about, but there are other advantages of spatial interfaces like proprioception, which is a memory of where your physical limbs are located relative to your body. Kinesthesia, kind of muscle memory and motion. This idea of a natural interaction, so being able to directly reach out and interact with things, right, rather than doing something like typing commands, and even something called hypernatural interactions. This is a term Doug Bowman uses to talk about things that you can't actually do in physical reality. You can actually go beyond natural interaction. So the question in my research that I'm going to kind of talk about today is, how can we take this idea of spatial user interfaces and spatial interaction, and how can we apply this to assist human sense making? So exploring data, problem solving, that sort of thing. So I'm going to talk about this through kind of three segments in the talk. So first I'm going to talk about in general this idea of spatial, immersive spatial layouts and some of the work in that area. And I'm going to talk about a couple of applications. One is immersive geovisualization, and one is in situ data exploration. So immersive spatial layouts, again, are taking this principle of placing information in space, but putting it in, well, sometimes putting it in places that are contextually relevant to that information, right? Or being able to recall it in somewhere. So not just putting it somewhere, it's memory in a memory palace, putting it somewhere where and interesting for you to use. So I'm going to talk about some of my early PhD work first, and this was to a large extent inspired by this work. So Mark Billinghurst, a couple of decades ago, now was looking at this idea of situating information displays around users. So as you're walking around, you can kind of switch quickly between these different displays, and have all this availability of information on hand, right? And be able to quickly browse between different things. So I looked at a project called the Personal Cockpit, where you essentially kind of take this to the next level. So you have all of these multiple information displays and looking at how to lay them out around a user. So these are kind of situated all facing the user, and they're kind of within reaching distance. So people can use kind of touch interaction. So this was simulated in a cave display, and we're looking at the field of view. So we had a 40-degree field of view width, which is kind of what you have with HoloLens and some other kinds of displays. So I'm missing the slide, but we did. I did a study with these where we gave kind of a problem-solving task, and people had to switch between the different interfaces. And we found that just by being able to switch, just by turning your head around, was much faster than kind of other more abstract navigation techniques, similar to the way that we use a smartphone. But another thing I looked at was this idea of different reference frames. So this is kind of draws from the work of Stephen Feiner, Windows on the World, and being able to attach information to different spatial reference frames. So you can have information that's kind of you could call it egocentric. In this top example, the body fixed interface, it just kind of moves around relative to your body, or things can be attached to physical things in the object, like people or objects, or say a wall display. And then you could have something like this where you have this personal cockpit, and then you tap your glasses and you go out for lunch, and when you come back from lunch, you grab your information and you go off with it again. And this led to the idea of this spatially constant layout. So what happens if you're going into different environments? How would you actually put these, if you wanted to integrate these with these physical surroundings? Where are you going to put these application windows? So you kind of want to maintain some orientation of how they're placed relative to one another, but you also want them to adapt to that specific physical environment. So in this example, you have this user, he's working in his office on the left, and there's this layout of these different applications. And then on the right, he's in a different room. So the orientation, the relative orientation of the displays is the same, but they kind of avoid important objects like these monitors that he's looking at. So this was kind of in the early days of the Connects. I used this Connect Fusion algorithm to scan these two different environments and did a visual saliency map just from a single image. This is a saliency map of that image. So the bright areas are areas where there's a higher, the algorithm predicts that there's more visual information there. So these are areas that you want to avoid. And then by mapping this saliency map onto this 3D structure, you can kind of get an estimate of where things can go and where they shouldn't go. So we did use a random walk algorithm to kind of create these layouts. So you can take your kind of ecocentric view and project this onto the walls, and it will remain, somewhat the same in both of these different environments, while avoiding kind of the important contextual information. This is just a view of what it looked like on a Moverio display which we're using at the time. So those were some of my early projects, but this idea of these spatial layouts has been, I have some more recent work. So some of my students at Monash have kind of looked at this in probably a little bit more sophisticated sense. So this is the work of Jiazu, one of our students, and he's looking at small multiples visualization. So small multiples is a visualization technique where you have a bunch of small visualizations, and you use the same data encoding for each of these. So they all have the same encoding, except you change one variable. So in this case, this is data from a building cooling system, and the one variable that's changing is time. So each multiple represents a different instant in time, kind of going from left to right, top to bottom. So he looked at, he was looking at immersive small multiples. So how would you visualize, probably 3D data in virtual reality? So you can have things like aircraft trajectories, or this building information model, like I mentioned, or something more abstract, like these 3D bar charts. And how would those 3D, how would the small multiples behave? So we looked at this shelf metaphor, where you could kind of change the curvature of the shelf. So by grabbing one of the handles and kind of squishing the shelf together, the shelf curves, or you can change the aspect ratio, like make the shelf larger or smaller, and the multiples shift accordingly. So we kind of explored a bunch of these different dimensions, and also looked at how do you interact with the data. So being able to manipulate not just the layouts, but the individual data. So being able to rotate the multiples, brushing of axes, and so forth. And so again, he gave some people a problem-solving task with these, a comparison task, and was looking at these different layouts. So again, you have this idea of this exocentric, something like you might put on a wall, versus this kind of curved layout that kind of wraps around you, which is you want to have things close. They're kind of near you. So there's some various trade-offs of these. So I gave them some tasks to to solve. And in terms of performance, he found that the this kind of quarter circle layout was kind of the best medium. It was the fastest performing of these three. And he did a follow-up study to see how this would scale. So there was only the first example. There were a much smaller number of multiples. We said, okay, what happens if you increase these? And we also want to look at a full circle. So what if you have a flat layout, a half circle, and this full circle? So kind of like a cave display that we used to have at Monash, where you have this kind of surround screen around you. You could have things like completely in this 360 orientation. And so it did a similar study with some participants. In this case, participants preferred the half circle layout. Again, the full circle, people found disorienting, so they found it harder to locate things and find them. The trade-off of the flat layout is there's a nice overview, so you can kind of see everything at once, which is kind of the part of the intent of small multiples, but requires more walking around, more moving around. So the half circle is kind of a nice trade-off between these two things. And in fact, Jiazhu has done a follow-up study. So I didn't have it, it's not published yet, but to give you a bit of preview, is looking at kind of spatial memory of these. So being able to, if you're doing a comparison task, part of that task, the idea is that you would have to recall the location of two different visualizations within this arrangement, right? So, and be able to switch back and forth between them. And so we found kind of similar findings. So that with spatial memory, the flat layout actually gives you very better recall, partly because of this overview effect, and the circle, of course, because you're kind of moving around and changing your orientation, it has some impact on that, on spatial memory as well. On the other hand, so this is another project by Katak. So he just graduated last year. He did this project called Maps Around Me, which is looking at this idea of multi-view maps. So if you have, this idea is you have this large overview map, but you can, if you have a problem where you need to see different regions and maybe at different scales, really to support this data exploration, you can have these multiple maps. So you have the main map, you can kind of cut out a slice and pull this out, and there you have your kind of detail view. And this is kind of recursive, so you can keep going, you can pull another slice out of this one and so forth. And then we realized that quickly you're going to have a very large number of these maps, which is maybe what you need depending on the task that you're doing. If you're trying to compare a bunch of different areas and you need to see information at different scales. But then this raises the question is where would people put all of these maps? So how would somebody arrange these? So this is the converse problem to Jiazhu's work, where you have these, we looked at these specific layouts of small multiples. What if you give the user control over these? How are they going to organize these if you let them do this themselves? So he ran an observation study where you have essentially give people a large set of maps and give them a bunch of tasks to solve and basically see what they do with the maps. So it's really interesting to kind of see what came out of it, and it turns out a lot of the majority of people would create this kind of what we call the spherical cap layout. So people, partially because of the UI, people could control the depths. We tried to make it as easy as possible so that people didn't have to have the interfaces at arm's length, because if everything's at arm's length, you just put it there, but they could move them, towards and away from them as well. And but this kind of spherical structure would arise, but the majority of people would kind of, so this is actually kind of aligns with Jiazhu's study in a way. So rather than the full spherical layout, people would create this kind of this half sphere. A few people did kind of a planar layout and kept them. This is kind of what we expected more of, actually, that people would treat it like a large wall display, right? But actually, in fact, that didn't happen, and people were kind of using this kind of 360 layout. And there was this kind of relationships emerged between the central window and these kind of peripheral displays. So each one of these colors represents kind of a group of maps, and people would cluster these, but have the main large map in the middle. Whereas some people would create this what we call a coordinated view, where you have everything off to one side and the main map to the other side. And then a few people did this kind of occluding layout, which you would think is not optimal, and they're kind of covering up other things. That was a small number of participants. I think one of the more interesting things is how people interacted with these maps. So here's kind of a replay of a participant, and they have this kind of central window layout. They have the main map, and they have everything around it, and they just kind of created this, and they did these tasks, and they just kind of left them like that. But some other participants actually continuously moved the maps. This was a bit unexpected, but people didn't just create the layouts, but they would continuously change the layout throughout the task. So in other words, the spatial arrangement is, it makes sense. It's part of their thought process. So they're kind of moving things around as they're thinking through the tasks. So the spatial layout is not a constant thing. It's actually involved, it's not just arrangement helping them find things. It's actually, assisting them to think through the different tasks. Okay, so that's some work about how do you arrange information around us, and I'm going to kind of diverge here and talk about a couple of different applications in immersive analytics. So this is CADIC again, and this is actually I just threw this in today. This is a paper that we just found out was accepted this morning. We learned that this is accepted to CHI 2022. So congrats to CADIC. This is about tangible globe. So essentially the gist of this is there's it's kind of a design space, but there's these three kind of different situations that CADIC came up with of how would you use a tangible globe to interact with augmented information. So globes are kind of this ubiquitous data visualization tool, but the information is constant, right? It doesn't dynamically change. It's usually just kind of printed on there, and you're stuck. So how can you kind of use augmented reality to make this more dynamic and be able to explore and interact with data? So in the first case, you have an augmented globe, where essentially you take your globe, it has a map, and you just kind of paint data over top of that. You came up with a few different use cases for doing that. The second use case is a tangible input device. So you have, say a larger globe, and you're using the sphere. Actually, let me just go into these examples. So this is the first one. So this is the augmented globe. I won't show them all, but he came up with a few different examples. This is one that's called a flow map. And so you have the information directly overlaid on the globe. This is a tangible input device. So the information is not on the globe. It's kind of more of an indirect controller. So you have this kind of large globe that you control, and you're essentially just using this as a controller device. And there's also these cases of complex interplay. So you can have these multiple coordinated views, different data visualizations, and here he's kind of using this as a kind of proxemic input device. If you put it near the graph, then it draws these kind of visual links that link different locations to the data. So yeah, keep an eye out for CADIC's talk at CHI. There's a bunch more examples that he came up with. They're very creative and a lot of fun using these kind of real world data sets. So this is kind of telling the picture about what is immersive geovisualization about, right? Using maps, being able to explore data interactively with maps, which leads me to this other project called Uplift. So this was a fairly recent project with some people at Monash, quite a number of people involved, including Fraser, who I worked with at Autodesk Research back when I was an undergraduate. And so this is looking at campus energy data on the Monash campus. So Monash has invested in this smart grid on the campus, and this will have a lot of sensors and things to monitor the energy network and so forth. So we got some seed funding from them to look at the how do you visualize that data, and how do you kind of explore it and use this visualization for problem solving. So the interesting thing we learned about this type of data is there's all of these different layers that you potentially want to look at, right? So there's the building occupancy, there's all of this generation going on. They have solar panels on a bunch of the buildings. There's electrical loads. So there's all of these different potential things that you might want to visualize and it makes for a very complex problem, like to solve, where are these peak loads coming from, and what's causing them, and what are all the kind of nuances of this problem, who's using that energy. So we thought we could build this collaborative system that would bring together experts from each of these different areas. So there's different people in buildings and properties at Monash that are looking at all of these different types of data. So we wanted to have this table as kind of a collaborative centerpiece where people could kind of share their knowledge and explore data together. So we put together a few different technologies for this. One is the tabletop as this kind of engaging collaborative centerpiece, some tangible interaction just to make it kind of intuitive and fun to use, and augmented reality to be able to be able to put data visualizations in places besides just on the tabletop, so above and around, using that extra space above and around the tabletop. So the tabletop display contained a map of the campus on the screen, and then we had these miniature models of the different buildings that use this transparent kind of resin material, and we could shine the light from the table to kind of indicate the color. So this is looking at the energy usage of each building. So of course the brighter color, the saturation is mapped to the energy use, the number of kilowatts that we use, right? So the bright orange building is the sports complex that's using lots of energy when the lights are turned on during the evening. So we wanted to make this tangible, right? You have these physical models, and of course, when we showed this to people, right away they want to pick these up and look at them. So you can pick up buildings and see different information about them. And we also created this other widget. So rather than, we said, okay, what happens if we avoid using the tabletop as an input device? It's a touch table, but if you could just interact with these physical widgets. We kind of have this energy cube thing that you use to select these different sliders. And so the point here is that you want to explore these different time granulars. So this is really about exploration and being able to kind of drill down in time. So there's all of these different time scales that are showing different energy patterns. So monthly view and the weekly view are going to show different things than a daily or hourly view, right? And we had this set of sliders where people could move this widget to these different granularities and kind of drill down. So you'd start with the yearly view and then kind of slowly progress deeper in time. So this is somebody moving the widget here. Selecting these different time scales. And then we also had augmented reality. So this is space-time cube visualization where time is represented in the up axis. So each layer is kind of a time slice, depending on the time granularity. So in, I believe this is the weekly view. So each slice is 1 day, and now this is the hourly view. So this is showing all of the, if you find a week that looks interesting, you can kind of go a little bit further and see, okay, so for this building on the right is using more energy during the evening, and this other one is using more information during the day, or more energy during the day, and so forth. And this kind of led to this another project kind of evolved out of that. So this is another PhD student, Nadine Zhang, and she is this is a project that's coming up at the VR conference in a couple of months in New Zealand. So this is looking at, again, at the space-time data, and the idea is really this exploration, right? So in our in this project, we showed this to people at buildings and properties. They're like, oh yeah, this is, we could see this being potentially useful. Then you could solve this problem, and this would help people to, explore this other problem. But the issue is that you have this one kind of single tabletop. So you can change the data visualization, but you can only kind of look at one thing at a time. So we said, well, what if you can create multiple versions of this table, right? So this is looking at how you can use kind of embodied interaction along with this space-time cube visualization. So this is essentially the same model of the campus in VR, and you have these, I believe this is the yearly view, so each slice is 1 year from the data that we had. And the idea is, well, what happens if you could kind of select one of these slices and you just grab it and you pull this out and you create a copy. And then you drop it over here and it becomes another table. So now you have two different tables that you can do some comparison with, right? And now you can stretch that up. Okay, so before we were at the yearly view, and now, okay, you grab 1 year and now you expand it into the monthly view. But you still have the previous table there that you can kind of look at for comparison. And then this is an example with individual buildings. So if you don't want the whole layer, you can pull one specific building out and it kind of appears on this pedestal. And there's these kind of links showing the kind of history of the search. And okay, this is stretching these up into the hourly view. And now you can do a comparison. So you have this is the same building from two different time periods. So you can look at the same building. This is the energy usage during a day on 1 week of a particular month, and you can compare this with the energy usage on a different week or a different time of year, something like that. So this is really about exploring this exploration process. And we kind of realized that it's also about being able to use this large virtual space for that exploration. So how can you make use of this large space and not only have room to put things to explore, but also potentially use this to kind of trace the history of your exploration. So this can help you, because there's kind of a storage wall on one side where you can put things where you're not using them. And Nadine in her next project is going to kind of look at how you can use this to enhance the kind of provenance of the exploration. So how can the space really support the exploration process by allowing you to trace through your search history and this kind of thing. So I think there's also potential for this kind of system and embodied interaction. I think I'm getting short on time, so I'm just going to go through this case very quickly. So another application is Insitu data exploration. So the idea is you have, building information model data. You have kind of these smart environments where you have, like in the microgrid project I mentioned, you have all of these sensors all over the place. sensing not just information about the electrical grid, but all different other kinds of systems within your buildings. And how can you look at this data not just necessarily through a virtual environment, but when you're actually there in the environment. So this is one of the projects I did at Autodesk Research, looking at essentially a virtual programming environment. So you can you have these kind of nodes and tube connectors, and you can build a functioning program that connects. Just skip here. Physical input from a sensor, use spatial interaction to construct the program, and you have physical output that actually, activates something. And you can also visualize the data flow between these different objects. I'm just going to skip ahead to the next one if I can. Skip button. No, I'm just going to have to fast forward through these. Well, here's a programming example. So there's this kind of trigger node. This is connected to a light sensor on the window, and you can kind of select some of the parameters. And the idea is that when you sit down in the chair. Oh, sorry, that's not the chair. This example is just connecting the light to the fan. So when there's some bright light, it's going to get hot in the office, and you want to turn on the fan to cool yourself off. So you can kind of run the program, and you can see on the bottom right there's a sensor tag, and I'm shining a. So this has an actual light sensor on it, and you can see the fan actually turns on. So this actually works. So it's actually really cool. You could kind of build and construct these programs, and they would actually operate. I'm just going to fast forward a little bit here, and I'm just going to very briefly mention this another recent project with Arnaud Prozo. So he was working at Monash with us. He's now gone back to, he's working at INRIA in France, and we're looking at a very kind of similar concept. So visualizing data in this kind of physical plant. So we have a BIM model on the left, and this is a scan of one of the plant rooms at Monash on the right. And there are all of these sensors in there, and how can you support maintenance workers kind of visualizing data within these? So in short, what we did was build an authoring tool, right? So the idea is that you need, if you have these situated visualizations, somebody has to design where they're going to go. So we said, well, what if you take this digital twin, we call it the Corsican twin. You have this, on the left is the real environment, but then you have this virtual scan. So the digital twin is in the middle, and you go into virtual reality, and you can kind of author these visualizations and put them where you want. And then you essentially take this, align you need some sort of calibration. So we use this QR code, and you place this in the virtual environment, and then you place the QR code in the real environment, and then you can view these visualizations in AR. So I'm going to skip this. So this is the kind of authoring process. Fast forward. Oops. I just wanted to show what it looks like. And this is the AR version. So this is one of our actual plant rooms, and this is, you can kind of export this, these visualizations that you've authored, and kind of look at them in the real physical realm. Okay, I think I'm just going to leave it there for the sake of time, and I'm just going to go ahead and let me just stop sharing here, and we'll let people ask me some questions.
So if you could raise your hand using the raise hand button, it'll keep track of who's asked their hand, who's asked questions first. But first of all, please join me in congratulating and thanking Barrett. Your first hybrid hand clap, Barrett. So so please use the raise hand button if you can. That would be very helpful. And I can moderate the questions as they come in. So Seb, formerly of the University of Sydney, but now of UNSW, will ask the first question.
Hi, thanks everyone. Thanks, Barrett, for a really awesome talk. I just had no idea that half of this stuff was on the boil. Something that occurred to me immediately is just how awesome it's going to be for a lot of students and researchers who otherwise have a lot of accessibility issues when it comes to tech and information and so on, and communications. And I was wondering if this is a sort of direction that you had explored or were thinking about exploring with the research in particular, and if there are any collaborations on this front sort of afoot.
Yeah, no, that's a good point. I think this is not an area that I've worked in, but there's definitely a lot of potential with these technologies. So there's a group at Monash, so Kim Marriott and Kirsten Ellis and some others are working in a group that's looking at accessible interfaces and this kind of thing. So I think one thing that they've discussed, I'm not sure exactly what they're doing in this area, but I know there's been discussions about how, well, I guess kind of from two fronts. So I guess, how can you use these technologies to make accessible devices? So people think of virtual reality as kind of a visual thing, but in fact, the point of creating a virtual world, if you think of the holodeck from Star Trek, it's this, what Ivan Sutherland called the ultimate display. So you have, he said, there's a quote from him saying that the ultimate display would be a place where you have, you can't differentiate it from the real world, and a virtual bullet would kill you, and this sort of thing. So you have real physics, you have 3D spatial audio, and potentially, there's researchers looking at replicating, smell and taste and everything. So you have all of these senses, right? So something like spatial audio is actually very powerful tools so that you can provide information to people, and there's this idea of data sonification where you can represent data using sound, and being able to put this in 3D space, I think, has a lot of potential as well, right? So
Jasmine Gouffond has been doing a ton of this stuff, and it's just wild. So
yeah, so I think there's a lot of potential there. On the flip side, I mean, I think because virtual reality and augmented reality, they are very visual tools. There's actually a lot of accessibility issues in design that need to be overcome as well. So these are not accessible technologies the way that we have them now. They have a lot of potential for it, but they're not designed. They're not highly accessible in their current form. So I think there's also work to do to make them more broadly acceptable. So there are opportunities, and there are also challenges.
yeah, absolutely. Thank you so much.
Thank you, Seb. So next up, we have a question from Rick. So Rick is currently in Latrobe University, but was formerly in North Carolina.
This is true. Thank you very much for your talk, Barrett. And thank you very much to whoever posted this on Twitter earlier, because that's how I found out about it and decided to join. So what really interests me is going way back to the beginning, your talk about memory palaces and song lines as sort of ways of organizing information. And I'm wondering if you've given any consideration to trying to combine that idea with the sort of small multiples work that Jiazhao was doing, in the sense that, if people naturally want to use a quarter circle or a half circle or a circular spherical cap to organize their data, you can put virtual walls there to encourage them to put their data on there in that way. But you could potentially also embed these small multiples in meaningful spatial arrangements to begin with. So for example, you could say, I'm going to have one cluster in Sydney and one cluster in Melbourne and one cluster in Darwin, right? So you could group these data in a way that has embedded meaning to its users. Is that something that you've thought about doing?
Yeah, that's a really good point. I don't know if I've thought about it in that specific way, but I think this is actually kind of the direction that Yadam's project is going. So the later one I showed with the timetables and creating these multiple tables. So you have this very large kind of virtual room that you can use for exploration, right? So how do you make use of that space? So I think some of the ideas you're suggesting, like having different shapes for different types of representations and different, you know, not necessarily having an empty room, but having some mnemonics. So if you put a garden in there now, as you're exploring, you can, this was the, I remember I thought of this thing back over there by the, you know, the begonia flowers, or, you know, under the fig tree is where I left that data about the, this other thing I remember. So I think that's, yeah, very helpful. I haven't quite thought of it in that way, but also being able to, yeah, retrace this exploration. So as you're moving around through this large room, you're kind of dropping visualizations at different places and being able to support, you know, the word we've been kind of that came up as we were discussing this project is provenance, right? So there's been work on supporting provenance in data exploration. So how do you kind of keep track of your progress through a very complex problem? And yeah, I think you're right. Having these kinds of features would, or potentially, I mean, it's worth looking into how those can be used and to support that for sure.
Okay, so next up we have Associate Professor Nadine Marcus from UNSW, but formerly from the University of Cape Town a little while ago.
Long time ago. Thanks, Erin. Yeah, no, thank you. I really enjoyed the talk, and I'm sort of a cognitive psychologist who works in this space. So for me, what was really interesting is that first memory study that caught my attention straight away. I was curious, do you know whether they spent equal amount of times in the three conditions? You mentioned the three different conditions. The one was the story, the other was the method of loci, and the other was just allowing them control. Did they get equal amount of times in the task? Do you know that or not?
That's a good question. Actually, I don't know that offhand. I guess, yeah, that would be, that's a good question, whether that would be controlled and definitely could have an effect. I imagine that they did. I'm happy to share the link to the paper if you like.
Okay, thank you. I mean, ultimately it makes sense. There's more recently quite a bit of sort of talk about linking the more ancient methods of knowledge into the online environment, and narrative is one of the ones that people are talking about. So that makes sense. But what I hadn't heard spoken about was narrative from a spatial perspective, and not just the story, but the space. So that was very interesting to me, to think about the space and not just the story in terms of improving recall and memory.
Yeah, it's very inspiring. So I think I've been familiar with this, you know, method of loci for some time, but I've lived in Australia for a few years, and I regret that I hadn't really become aware of songlines much earlier, because I think it's very interesting. And
yeah, I think there's a lot of that sort of thing in all the different indigenous cultures, you know. So I mean, I think it happens, and from the little bit of reading I've done in the area, you know, there's a lot of stuff in those cultures and ways of remembering and recalling that can be applied better in an online environment. So it was interesting for me to hear that. So thank you very much. I'm happy to chat further at some stage.
Sure, yeah. Maybe if maybe Erin can put us in touch by email, and feel free to ping me or look me up at Monash, and you can find my email there.
Okay, thanks. I'll do that.
Very good. And our last question for this evening is from Professor Judy Kay from the University of Sydney. Now, Judy makes it difficult because her previous institution is also the University of Sydney. However, her most recent sabbatical, I believe, was in the University of Haifa, unless I'm very wrong.
Actually, University of Michigan.
Michigan. There we go.
More recent,
your digital footprint is very well hidden, Judy.
Okay, I'm really pleased I got a question in, and I'll be catching up with you anyway. I was just wondering, you know, if you had a magic wand and could put this into making education revolutionizing education, doing cool stuff with education? What would you love to see happen? Or do?
Okay, so education is not my expertise. I have been involved in a couple of projects. So there was a student of Mark Billinghurst I was helping on some projects. His name is Bradley, and he was looking at using augmented reality to kind of assist tasks and help with learning. It's really interesting stuff, and I'm happy to point you to those projects. And I think,
I actually do know those. I just thought,
okay.
Yes.
The challenge with those works is just the learning is a terribly difficult thing to measure. It's notoriously hard to measure if somebody is learned. You can measure, so the focus in a lot of these studies tends to be on engagement and enjoyability and this kind of thing. I was recently involved in a CRC project with some people from engineering and some companies that are interested in vocational training. So there is interest around applications for this, and how do you how can you apply this? So I think the key thing is it's not going to be useful for everything, right? So of course it's going to be useful for distance learning potentially, or situations like COVID where students can't come to class. But then the real benefit is where you have something spatial, so a spatial component in the learning. And so there's a lot of discussion with that project about how this is actually going to support learning objectives, right? And there's I think there's just a lot of open questions, and I don't know how do you design the content, and how do you make it affordable to do that you're not, it's going to be like 10 times as expensive to build this with the media thing. So I'm sorry, I don't really have any strong answers because it's not my area, but I think there's a lot of open questions, a lot of interest in these applications.
Great. I look forward to chatting with you, and I feel I should. Tim has a question about field of view, which I'm also interested in, because I had some students who worked for Meta, and field of view was a misery in that AR stuff.
Yeah.
Sorry, time. You're right.
Time. We have to respect the time, unfortunately, with respect to these talks, just so we can let everyone go free to their next event at 5 p.m. Anyone who's here in Sydney and would like to come to the Regent Hotel for a drink in Kensington, Barrett will be there for at least the next hour, and I know only an hour because he's going somewhere else after that. Please come along, but obviously get in touch with them. Google Barrett Ens, Monash, that will find you, pretty sure. And he's here for at least another couple of months, aren't you, Barrett?
Yes, that's right. Yeah, at least a month, probably more.
Yeah, maybe longer.
Just put my email address in here as well in case anyone wants to just copy it and. Great. Okay.
Great. Well, thank you very much. And thank you to SydCHI for allowing us to host this talk through the SydCHI network. We look forward to seeing you at a future SydCHI event, hopefully more together physically, but online also works too. So thank you all. Have a nice weekend. Thanks, Barrett.
Thanks, Aaron. Thanks, everyone.
Thank you.
Thanks, everyone. And thanks, Barrett and Aaron.
Thanks, Nadine. See you soon.
Bye.
Bye.
Bye-bye.